Okay, so nice to meet everyone today. My name is James. This is Linux Accra user group, and today we'll be talking about compiling a custom kernel on Arch Linux. I just mentioned the Arch Linux because it's Arch Linux. You can actually compile it on any of the distros. So, in this guide, we'll be talking about how to compile the custom kernel. It's a bit advanced because, to be honest, on day-to-day basis, you don't want to compile that, but we are going to do that to just show you how Linux as a kernel operates and what it does and how to build your custom one. Sorry, I couldn't zoom this the much I could get because it's presentation. Okay. Okay. So we asked why we are going to compile a custom kernel. So first of all, for hardware optimization, so if you want to compile to a specific hardware, you can do that, and when you compile it, you can remove the generic S21 and just know that you're compiling for your system. So the other one is shedding dead weights, which is removing excess unused drivers and modules. So this is a case where it comes to something like this AC. It's running the kernel, but it's not going to run. Like Wi-Fi modules, and so because of that, it becomes slow. So I want to show an example, and I need you to take point of this. So I have a USB here, and when I plug this USB, it's supposed to show up in my system or make a sound, but nothing happens. It's well plugged in, so it's not showing up. Neither is it showing anything on the system. Can anyone take a guess why that is? The USB works, by the way, but it's not working on my system.
Okay, so there's no driver or something for notification or something on this phone. Take a guess.
Okay, the guess is right. There's no, but it's not notification. I'm already running the custom kernel where I disabled USB interface. So all the USB drivers do not work. So whenever I plug something in the USB, it's not going to respond to me or even mind me. Yeah, but my charging is working. Type C, USB, every USB interface is not working. So because I disabled it while compiling this kernel. And just to confirm that we are running on custom kernel, when you're running a custom kernel, you can actually set a unique ID for it, just like this. So if I check on uname and find arrow, we see that I'm running 6.19.8. My kernel Accra was the one that configured the kernel, so it's a custom kernel that's running, so not my Arch kernel itself. So that's how I get to disable that. So we go back to this. So we also have for cutting edge features. So some features, the kernel has a lot more features that we don't use because the distributions, the Arch, the Ubuntu, the Debian, they all compile the kernel to suit the wide variety of users, of laptop users. So they are not going to enable 100 features on their app kernel. So they're not going to add some microcontrollers like these guys. So they have a lot of features and options you could configure in the kernel, but because you are giving it to a distro, you are putting it in a distro where generic people are using on their laptop, you just put in the features needed for laptops to run. And the last one is just bragging rights, just to be honest. So I use Hack, by the way. And then also brag that you compiled your own kernel. It's also a nice brag. So we move to the next one where we have the steps to getting the kernel is the source code. So before we do that, we also need to get the tools to compile your own kernel. So you need the development tools like Make, like GCC, and Make, and Automake tools, libelf, and CPIO. These are tools used for getting the compiling the kernel. You have the Git, you have the tar, and the SZ. So here is to install it on Arch, and the other one I have Debian. I'm looking for my mouse. There you are. Okay. So we have for Debian systems, build essentials, BCK mode, and CPIO. For Fedora, I wasn't able to get it. I didn't have enough time, so I just left it there. So I believe they have. And then you have to ensure you have plenty of space for building the kernel. The kernel is quite large, about 3 gig. And sorry, not 3 gig, that's the history, but the kernel itself is about 150 MB. But when you build it, the build files are going to explode all over the place. So there are two ways of getting the source, but you can't just download the kernel. So when you ask me techie people, the basic stuff of can I just get the name of this file? And they want to show you around the kernel. They come in, just give me the file. There are easier ways, but I want to go the longer route to show you. So we get that to the next file. So you can actually use Git. So I trust rely on Git because you also get the latest one. You get the latest code. You also can read the latest commits or the code changes that has been made. But when you use Git, it gives you control to see the entire source code, and you also make modification. You also see the code that was written 2002, and you also see the commit messages. So just to show you an example, I have a Linux here that I pull from Git. So if I do .git log one line, we see all the commits that has been made, the ones that Linux Server merged, and the one people put up. So as you say that, let me say these are all merge requests. Okay, let me look at this and say I'm getting to Git show. We see the commits this guy made on Tuesday, March 10th. It's some guy at Sabrina. He made a commit, and these are the comments of what he did. He removed some attributes, and if you look down, you see who signed it off, who reviewed it, and they link to the patch, and you see the code that he actually changed. He just removed few codes, and this is the code he made. And I think he just added an if statement. Maybe he was crashing without an if statement. So he added an if statement to make sure the protocol is available to write, to avoid the unaccessible address that he was retrieving. So this the point of using the Git. And we can switch versions. You can look at here to see Git tag. This is the versions of the Linux from version 2.6 as early as 2.6, and now we have about 6 points. We are at 6 points or 7. The next one is 7.0. We're about to release. Let me go faster. Yeah, the ROCs are still being worked on. So you can check out any of these. Maybe you want to pull the kernel from 2.6. You can pull it and compile as you want. So the other one is because you feel like a badass. You just feel like using Git is better. It's better. So we go. I wouldn't want to use this one because it's slower, but we also have the next one, which is the HTTP. You can download it from the HTTP, like the website, download it from the website. So we can just download it from kernel.org, which is where you get the download URL, and you download it just to show an example here. So if you go to kernel.org, here we have the kernel, we have the latest one. You just click on this download and download it. So you get the latest one, which has been done, and that's how I got this one. The URL 6.19.8 was the one I downloaded, and when you download it, you have to extract it using this command to extract it. So the only reason to download this is because the size is smaller, 150 MB. Or if you're doing for Git, you download about 3 gig. So you can just use this one for the smaller one, and you just want the kernel, nothing else. So I'll go back to the one I downloaded. Let me see. It was here 6 points. So I downloaded and extracted it just like I specified here. So I seeded into it. So here we have the files. We have the files here. We have where the codes are, the drivers, the includes, and everything that involves the kernel. So this is the kernel here. And the next thing now, preparing the environment to say that we are going to build it. To do that, there's just pre-measures to take, but it's unlikely to happen. So when you extract the file, just make sure that you set the user ownership to yourself, so that in case when you download it from HTTP, sometimes when the files are compiled, the permissions compile with them. And when the user comes, it becomes an invalid ID. So you can do that. Based on our previous meeting, we showed how to also change permissions, change the owner to yourself. And then you run a code called Mr. Make Proper. I will not run this code now because when you run it, it cleans up the build files that was built in the previous one to make a clean build. But if I do that, the next compilation will take about 30 minutes. So I'm going to leave it so it will make compilation faster. So if you run that, thanks to the developers, they just have a command make proper, which does that and cleans up some files like the already compiled ones. These files were compiled files, the .o files. All they see compiles object files, so you just clean them up. So now we go to configuring the kernel. So when you get the kernel, the only option you want to do is to configure it. If you're not editing any code in it, you want to configure the available options. So you have to find the config of your distribution. So why would you do that? So if like I'm using Arc, someone that is using Ubuntu has to find the config file of Ubuntu to make sure you copy exactly what your distribution has as enabled. Because if you start all over to edit the config, I'm not sure you can finish today because you don't know all the options. So just to give you an example of what we have in the config. So we have each config, and you don't know what all of them mean. So these guys have already compiled, provided their own, the GCC version, the versions of different things. From there, you go to general setup, config has kernel, and the kernel has LZ compilation, gzip. So you have to do all these things. Then you still go down, the most numerous one is the drivers. The drivers, we call them modules in the Linux. So you need to know which one to enable. If I go down further, the list is very long actually. So you don't want to do this and start seeing which ones you enable or not. So you take your distribution zone, then make slight modification with what you want to get. So in this case, in Arc, it's more easy because we have one that sits at proc.config.gz. So we just take that. In Ubuntu is in /the boot file config. You see the config file there. So what I'm going to do is I'm not going to, because I already have a config which disabled the USB. I'm going to enable the USB again, and then so I'm not going to copy the config, but you can copy that. So the config comprises of three options: either yes or no or module. So yes means that you want to enable this module. No means you don't want to enable it. Then module means that you want to enable it when it's needed. That means when you plug your USB, the USB module is loaded automatically. So that's where the module comes in. Then the heads up is that you want to edit your config.local version in the config file to avoid overwriting your kernel. So once you pull a custom kernel, the one thing you want to do is to edit this value, config.local version, and that's where you saw my value. This value, that's where I got this. If I do not change that, it may override my own kernel when after compilation. So I want to make sure I give it a unique ID. So to do that, you just edit the config as well and say, what's the name again? Local version. Let me search for it. So we see here so I'm just going to do another one for another kernel. Let me say this is called 2, append 2 to it. So and also just append this here. So we have a new local version, so that when I'm building, I build a unique distribution, I save it. So after saving, we are still on configuring. You edit so there are multiple ways to edit config. The one I just did is the first one, the raw config yourself, which is also extensive. And then the second one, it's nconfig, is a command line for changing it. Let's say make nconfig. It gives you an interface where you can edit your config. But I prefer the GUI one in this case. Okay, we have an error here. Nconfig should have fit okay, my terminal the terminal is too small. So we will skip this one, just use sconfig. It's another GUI based on Qt for that. So here we see I can't zoom it because so we see the check mark to see BPF system. You see it's not enabled. The file system is not enabled here, and so it's not coming up on this kernel. If you try to run it, even something like ACL should also be in this place to enable it. If you don't enable it, our last one. So there are many features like Linux get support, mitigation of CPU, ACPI2, you have to enable it. It's mostly about power configurations. virtualization. If I disable this, I can't use Oracle Virtual VM on my laptop. So these are features you need to, the OS has enabled by default network support. If you disable this, you entirely not get a network interface on the kernel. So when each feature you disable reduces the size of the kernel when compiled. So in this case, I think I disabled, the only thing I disabled was the USB, so I have to go back to enable it. PPS, pin, data. Sorry, I'm moving too fast. I was familiar with what I saw last time. Yeah, USB support. So all I do is to enable it, enable all the subsystems to make sure everything is here. Yeah, oh, it's this module, this. I'm not sure what all of them means, but I'm just going to enable all of them so I can get it to work again. Oh, I don't want to disable external hub. The ones that are marked new means that in the previous config I got from the ARC, the option was not there. So in this new kernel, they added it. So these are new. So I can have to enable serial converter support, enable this as well. I think that's most of the USB pin there. Type-C support as well. So you can actually remove the Type-C support. Okay. So, is it what? Which one? Yeah, okay, yeah, these ones. Yeah, I'm going to enable them. This is stressful actually. But if you know exactly what you're looking for, you go straight to it. But now I have to enable everything so my system can work properly. There are lots of drivers here. Some companies I don't know of, MCT single port. All the driver, both for cars, for microwaves, everything. and you compile everything, so that makes your kernel very big. So when you just disable some things like GPS, USB, this is a GPS device. So these things are for devices, even for data. SanDisk will be somewhere there too. For mass storage, it will be somewhere there. So these are all the drivers of USB. So you want to enable, let me just, I think this should enable all of that. So this converter supports gadget Type-C. So when we do this, we save it. Let's see that if the next one solves it. So when you do, you close, you've already configured that. So the more you configure, the bigger your kernel, the less you configure, the smaller your kernel. So like I mentioned, the make S config was the dialog we saw. The other one didn't run because my screen is too small. Then the G config is the same thing, but GTK. There are two display managers in Linux, GTK and Qt. So the first one was just another look. So now we are done with the configs. There's not much to do unless you want to edit some codes and the kernel source code itself. But when we are done, you can now start compiling your kernel. And to compile it, thanks to the kernel developers, you just have to run make. So make builds your kernel, but you want to also build it faster. So if you run make alone, it's going to run single threaded, which is will take time. So you want to use J to specify number of CPUs to use, so it's faster. And to get that, if you want to use all the CPUs on your laptop, you just use mproc to get the number of CPUs. I have 2 CPUs on my system. So what I will now do is it's physical. Yeah. So what you want to do is now do make and J12, and this starts compiling the kernel. Yes, it will make use of the 12 CPUs and it starts compiling. So we give it some time. If you look at here, You see my CPU is overloaded, which is 12 of them. This is each of the CPUs up to 11 starting at index 0. So it's all overloaded. They are all compiling the kernel now. So while we wait for it, we will take any questions that you may have and discuss other things. This will take about 10 minutes, yeah? Yeah, Oh, unless you want to actually edit, that's why I say it's not really necessary for a day-to-day user. Unless you want to edit something in the core code or you are preparing it for maybe a small microcomputer that you want to put it in. Oh, okay. So it's compiling the drivers, wireless driver, Realtek, MediaTek, all of them. They're all there, compiling them all in one kernel. So that's why when you load Linux on the phone, it loads. You load it anywhere it loads because most of the drivers written way back are still operating in them. So yeah, there's a lot of drivers. Yeah, backward.
Made Linux very strong.
Yeah.
There was a lot of work done on the drivers.
Okay, I think my compile went faster. This VM Linux.
Stuff so that it could run on many machines.
Well, the old telephones drivers are still there. The modems, USB modem 4G are still even there as well. So I think it ran faster because getting to VM Linux, which is compiling the image itself.
Yeah. Unfortunately, I met VM Linux when I crashed my system.
That's why you know the system. But that's the image itself.
Yeah.
That's the compiled image.
Yeah.
So let me see if we go further, then we wait. And yeah, when we wait for this. I doubt that the features are enabled might not cover all these things. I think I might have missed something. So to fix it, I'll have to copy back from my distro what they enabled and override my config so that they enable everything that I don't know happens there. So if you need to edit, because I was part of it when I bought this laptop, some keys were not working, so I had to reach out to these guys. I was part of the engineers that fixed it. So that gave me opportunity to. This was one of the issues we were resolving this laptop itself.
It's a Zenbook,
yeah. Yeah, Zenbook. So we were dabbling with a lot of codes to find out the issue. That's where I had to. That was my first time compiling because I had to test the code and run them. So I have to compile my own kernel whenever I edited the code. I think this was the code. So we are mapping the keys because the keys were not That's why we have issues with compatibility in Linux. The manufacturers do not give us documentation. Yeah. So we have to do try and error,
reverse engineering
to see it. So when ASUS and they don't give us for Windows, they'll give them the documentations and the sound pins like the speakers. My speakers were not working properly too. They said they didn't have the sound pins because what we had to do was to reverse engineer, going to boot onto Windows and collect the pins, the system pin, and come to Linux. So you have to boot in and see what they did there and then implement it. So
I think, Mr. Sanji, I think we also had a problem with the bootable drive, which the mouse
wasn't working.
Yeah. Like it says, the mouse is not working. What do you mean the mouse is not working?
Yeah, so Microsoft Surface, the keypad and this thing doesn't work in Windows by default. You have to install it.
Yes.
So it was a part of what I was part of fixing. And then when I was trying to, when I was trying to join the contributors when Linux Foundation, I was doing some challenge, the pillar challenge, where we had to write modules. I had to do that one day, how to write modules and drivers.
Yeah.
Linux.
I'm interested in for myself.
Yeah, you have to write, but you have to know C. They're doing some errors.
Yeah.
But it's C that we used to write modules, to write character devices and stuff. That was also where I had to travel into the kernel as well. So we just wait for these to compile. It should do faster.
And this is 12 cores.
Yeah. Imagine a 12 core. and two cores.
I remember when I was when was it? I don't know whether it was C or C sharp or Java. So this is like way back in 2013, and it was talking about when there's a problem, then
Mhm.
quickly
Yeah,
it
to
will give
re-
you an error,
yeah.
and then it says okay. So when there's no problem, what you do is that you see that the thing is running, and then go for a coffee break.
Mhm.
I say but what do you mean go for a coffee break?
Oh, okay.
Why I cannot just be there and
No,
watch
no,
a
it
thing
takes okay.
happen.
The compilation takes time.
Oh God.
Yeah, it happened to me
Oh
when I
God.
was doing that. If you fix something, you have to compile
You have to compile.
one. So before you run, running is expensive. So you have to make sure your code using ice to make sure everything has run
Yeah,
before you can hit compile and then go and rest
yeah.
more and come back.
I think that is maybe that's the reason why the interpreted languages like Python and the rest are
Yeah,
because
because it's fast, instant.
to be very honest, if you don't have that patience, if you don't have the patience to be waiting for things to compile,
Yeah. So we have
oh
our image
goodness.
ready, like you said. The kernel image is ready, and but we are not entirely done. So what we have here is the image, but let me see. How do I make it? Sorry, I need to make it full screen again. So see. So the next thing is to build the modules. So we built the kernel, but we've not built the modules, which are the drivers. So to do that, we still have to do that with make module. Well, in this case, it doesn't too much because I've done most of it, but it wouldn't take time. So this will just build the module. Then we have to export the modules to somewhere. I will say we install the compile modules to your file system. So it goes to this part, lib modules. Let me just do another. It goes to every kernel has a module here. Oh, please. Don't show all of you. I think modules, yeah. Yeah, so these are all the kernel I have, and I need to even delete some. So it puts their modules here so that when they come, when the system is loaded, it knows where to find them. So this is my default arc module. This is the one I did. These are that when I was fixing the sound, where I was fixing the sound and doing that. So it takes some space. I need to delete them. And so we have it's still compiling the module. So it's fairly easy if you're not changing much. So it's done. So we just do now for this one, we need to run make modules install so that it copies the module to the right part. So it's copying it based on the ID I provided. Remember, I put 2 at the end. Else the kernel won't boot because it won't find the drivers. So yeah, yeah, these are the things to run the system. So I was sensing in documentation there were places I used hash and there were places I used dollar. Does anyone know the difference? So if you can, yes.
Will you try?
Okay.
No.
Oh. You have to put it in the last so our audience can hear it.
So if the prompt is a hash, you are running
Okay.
as root. But if it's a dollar sign, you're running as a user.
Okay. Yeah, that's correct. So we are going to run this as roots because we need to copy to some parts where only roots can copy, like lib modules. So while that is copying, after that, we move to copying our bootable image to a path. So this will take a while. It's on this lib.so files that if someone deletes your lib.http.so in this my brother has an issue where the file was missing. No internet activity can happen on the on the laptop any longer. Just one module file. So it's like your system 32 in Windows. So if you delete any library of here, the whole system goes in disarray.
It's very difficult to delete the system to I don't know if you tried it.
Oh,
Which was?
system
System
32.
That's what about Windows.
We are
Yeah,
talking about
Windows. Yeah.
Yes, of course.
It's very, very difficult.
Responds every time.
No, it doesn't
So you
spawn.
can't delete it.
You can't. I think it's run as admin. You can delete as admin.
No, it doesn't allow you.
Maybe it's recent. We
So-
used
so
Windows.
I-
My last Windows was Windows 7. So
I even used this thing. I even used some privilege escalation
and it
exploits,
doesn't any longer.
and I didn't get administrator. I got NT. I got the highest, which is I think it's NT user,
So that's the
and I
interesting.
tried to delete it. It didn't delete.
Oh.
It
So
didn't.
that's the interesting thing about Linux. We give
They've
you
made it so
gave you
difficult.
the flexibility to actually do whatever you want. It's left for you. So we have copied the file and we've copied the modules. Now we have to put our image into a place where the system can see it when it's booting. So like we say, we have to copy the kernel. So which are already generated. We already generated, so we now run the second command. So what I would do is to copy from copy. You need sudo because it's a place that requires sudo. We go to x86 from the path where it dumps the. I think it's boot. Then we find bz image. This is the kernel image, and let's just find the size of it. This is about 15 gig. Megabytes. 16 megabytes. I mean, if you're rounding it up 16 megabytes, but if you're looking at it by bytes, it's about 15.7 megabytes. So that's the size of the kernel. Meanwhile, some of our JavaScript apps are using 50 MB. The JavaScript apps are using up to 100 MB for apps. Why? So this is the size of what is running those apps. This is the size of it. And then we are going to copy this file. I should have taken it. Okay. So we copy it to boot. No, we are copying. It's there. Okay, back up something. No, we are copying to a new file. We are not replacing that one. They have custom one, which is the one run. I have the Linux one, which is the distros one. So this one, let me say, is custom 2. So it's copied to custom 2. so after copying, we've copied that. It's ready. Then the next one, it's what we call initial FS. So initial FS is what makes it flexible that everyone can boot into the device, into the kernel with their devices. So initial FS is a small initial RAM file system, is the full name. It's a small device which loads when you boot, and when it loads, it takes a very little drivers like file system, devices like USB, and then finds your kernel and boots them. So without this, you wouldn't be able to find the kernel on separate systems. So it builds every time that a new kernel comes into your system. It takes your, the mapping of where your disks is at and stuff. So you can't actually move one initial RAMFS to another system. It's unique to each system. What is now generic is the image itself, the kernel image. So we need to build a initial RAM file system which sits on the RAM whenever you build. So to do that, I have to create a new preset, and the new preset is where it finds the kernel to build. So a new preset sits at etc make CPIO. Make init CPIO, sorry. And here, let's take for example the custom one I have. So if I'm saying to edit this, let's see the content. So we see that it has all kernel, the kernel that I'm using, which is this one. The destination, I'm not sure. Okay, this is where it's supposed to output it if you give it a specific name. But if you do not give it a specific name, it's going to output it at something else. So this preset is the two images it's going to provide. It's going to provide the default and the fallback. The fallback is when the kernel is unable to load, you're able to use that image to figure out what error you might have. So we also have the default image where the name of the output of the image, which is this, and then I copied it and modified it. So now I'm going to copy this one to modify for the next one. So just to now I have to do that's the standard. So I just modified the base, the base of so I have to make a copy of it so I can just modify it for the next one. So if I take this, now this is where you have a bash expansion. What is that? Was it two? Was it two? So, it was two. Okay. No. I have to copy this and do another one. Yep. Linux custom 2, the presets. No such file as which one? The preset itself. No starts. I have to copy the first one and copy the second one. It was a space. So if I do ls etc making it cpi.d, I have the two. When we copy the first one became the first argument, the second become the two. So I replicated it for us. We have the second one called 2. So this one I'm looking for custom, and I have to just edit it to edit the value. So in this case, I added 2 to it, custom value 2. Remember that I'm pointing to this file. I have to zoom this again, sorry. Remember I'm pointing to this file I copied, this one. So I have to make sure the name matches so it knows where it's looking at. So I'm providing the name to this part, custom 2. And then the next one is the default, which is also have to add 2 here. So that on my boot record, I have them unique. If you make this mistake, it will override the one. So you have to make sure the names are accurate. So I have to have custom 2.
I'm guessing how many tries you used before you figured that out.
Actually, today myself, the first kernel I compiled ran into kernel panic because it was a typo here actually. so if you make a typo, your grub might not find it. So you have a kernel issue. You can't find it. So we all learn by mistakes. So when that is done, we have a preset called Linux Custom 2 preset. So to now compile and init ramfs, we now do a sudo make cpio. Where is it again? No, it's not. I think I have forgotten the name. Let me check it again. Make init cpio. Okay, there it is. So using p to specify the preset. So we only build for that specific one. So I just put Linux and the name is there, custom 2. The one feature I like so much in Bash is autocomplete. Autocomplete. So we have custom 2. So I'll just go ahead to build it. You see that it's building the image from presets. I'm building everything. So like I mentioned that, what do you call it? It's done. The init file system has very small features. If you see that it's running build for base, system D is needed to boot. The base is in the auto dictate. Microcode is needed, which is microcontroller. Mode conf is needed. KMS, keyboard, map, block files. These are all drivers it needs to actually find the kernel. So it builds a very small kernel itself that it runs to find the kernel itself. So it has boot the output to this place. This is the fallback. The other one is at the top. So when this is built, everything is ready to boot, but not entirely because your boot manager does not know yet. We also have to update the boot manager so that when you boot, it sees, oh, there is a new image. And for that, I use Grub. There are other ones. I'm only familiar with Grub at the moment. So to do that, in Linux, what you can in Ubuntu, we usually use update Grub, which is okay. But here in Arc, we use the native one. We do Grub make config. So what Grub does is it goes through the images on your boot folder to find your images. So if I don't provide any other thing, it's just going to do that. So it goes through, let's say, okay, let's start afresh, the output. This is the config that you have queued. So if you start from the beginning, there are comments I need to point out. So it's searching for this floppy disk, and when it searches for it, and so you're searching for custom ACP, I put something there, it searched for that. So it found an image, if you see the first one, which is my Kernel, found an Linux image, it's added to entry. The menu entry is actually now, this is my default one. It found the initial RAMFS as well, and added it. Then it goes to the next one. It found advanced option as well. So it found another one, which is the custom one. He added it as well. Then it goes to the next one. It finds this one. So it has found it, and it's also added to the config. So this config is the output. I'm just going to put it where it's supposed to be, which is O. It's in boots and grub2.clg. No, there's something. Yeah, grub.clg. So I'm just going to, yep, so we have that it's searching for all the images, and it's able to put them in the boot. So now all is done. All I can do, what I can do now is to boot the system. Moments of truth. So I wasn't following them. So when it's done, this is the moment of truth. If he boots, then we did it well. If he doesn't, if it doesn't boot, so I'll have to do that. And so I have to, yeah, it's done. Let me see. We are testing out if it actually works. Okay. Let me shut down this part. Let me restart. I'm not sure that grub shows in a projector. This is the rebooting part.
So I was very I don't know. Okay, the word is not short. But System D. I don't know if you know of the System D battle in Debian.
In Debian?
Yes.
If I know about what?
The System D battle.
Oh, the battle about init D and System D.
Yes.
The old ways and the new ways. Yeah, I don't know.
No, with System D and init RC.
Init D, yeah, they call them init D.
All those the other ones.
Yeah, they I've forgotten what they call. They run levels. In the run levels, init D it's the old one. System D is the new one with new features. And I know the battle those times.
And there are newer ones.
There are many of them.
And the Debian community has split from now. I think they call themselves Dev One.
Oh,
I don't know if you heard of it.
no, I've not heard
So
of it.
the main difference being that old school Debian guys follow the System D approach.
Okay.
And then the guys using the newer versions of the newer or the other
newer versions of System D.
Of System D, which is like I said, the OpenRC. The OpenRC. They have much.
Yeah.
SysV in it. There's one called
SysV is old. Init D is SysV is old before Init D came.
So
Init D came and then System D came. System D has much flexibility.
So then from the way you are speaking, then it looks like there were some improvements on those older guys to bring out something new, which is not System D.
Oh,
and
yeah.
then these guys are pushing to make Debian or a version of Debian which is not using systemd, or they feel like they have a much better in it?
I think the problem is also that people just like what they are used to. Coming to learning new stuff again is a problem.
Yeah.
So if the newer generation will have something new, they can use it. For the older ones, then I don't.
I think systemd that's the way.
Yeah, systemd has a lot of features like timers, services. So Init does not give that. Because actually, it's shown here, but it can't because Grub doesn't detect other ones. So we can see here. I'm going to boot into it here, the custom 2. I think it will show up there now.
So I just hope the HDMI driver.
Yeah, custom 2
wow.
at the top. It's booting it. We were successful. So we have to put the USB.
Okay, yes, you check whether
I think something. The HDMI is messing up with my input.
okay, so it's on your machine, but it's not.
Yeah, I can't click on the wait.
Okay.
I can't click on.
You can't click on
Yeah, that's the thing. I think I have to unplug for a while. Let me see if it fixes it. Okay, thank you. No. Okay. We are logged in.
Moment of
put it back. Let me put it back.
Moment of truth.
Okay, so it's up and running. So I can plug back this.
Yes.
First of all, let me check the kernel so we are sure we are running
The modified kernel.
Yeah. So we do a uname R. So the 2 is the one that's running. So if we plug this. So the USB was enabled.
Yes.
So if
we hear the sound.
Yeah, so if you unplug it, it also goes out. So you see that the features of the kernel can be configured to remove some features and support some things. So most of the devices, like these ones, the ACs, not the lights, but the ACs, the smart ones are all running on something. So mostly Linux because Windows, it's heavy, obviously. And it's what they call it, it's paid. It's proprietary, yeah. So on Linux, you can use them to run your little devices for your practical, for your hardware. So to do that, you need to disable a lot of features. But I think AI can help you as well to shred down the config, pass it the config, and say you're building something to just detect the internet. You don't need any other thing. You can point out which of the features you will need, and then when you compile the code, it could be 5 megabytes or 2 megabytes after that.
And yet it's still a Linux kernel.
It's still a Linux kernel. So this is the end of my presentation on compilation of custom kernel. If you have any question or any discussion, we can take.
Thank you.
Okay, it's my pleasure. Okay. So we just go with if any other question or anything you want to, even if it's not related to the custom kernel. Oh my God. That's how we all learned because we all broke our system at some point.
You can use the alternative because that's what I saw. I think when it was in the config file.
Okay.
Because you said that yes, I think it's it's an initialization file.
Okay, the fallback kind of thing.
Yes, where if they couldn't find
the kernel,
it would go to
the next one.
The default.
Yeah, it has a list of. It sees the list of kernel in your system, so it gives you the option, the list of options, so that you see if you want to boot from and reboot from the previous kernel, it's still there.
Because,
The one that I disabled with the years. So I boot it my US old work. So it finds all of them and to be able to boot them.
I think, but isn't that how everything is based on? Even for Windows, so if you have a problem, you can push from a if you have done an update, which is like a make.
I don't know about now. Last time I used it, no.
Is it
No,
our
because
It's a,
say if you go back to Windows, because like if you did an update to the system and something went wrong,
Mhm. Can you roll back?
Yeah.
You
So,
can't.
but it's this thing. What do you call it? System restore.
Yeah, the system.
Oh,
System
that.
restore. However, depending on the organization, it would be enabled for you
Okay.
or not. If it happens at the moment when you were installing, and then for some reason the machine crashes, then it will roll back. However, unlike this where you can choose when like you
Which
boot
one
into
is
this and then you boot into that. If system restore has not been enabled, it would
like taking a snapshot?
like taking a snapshot. So that's the Windows name. Yes,
Okay.
system restore.
So I suppose is it. So what you could have is you have various kernels,
Yes.
and perhaps it's possible that you've got various drivers and set.
Yeah.
So you can decide to flip and decide
Yeah,
which
flip.
of the listening.
Yeah.
So depending on and so you'd have multiple.
Kernel.
You have multiple kernels. So you also have the configuration file because that's what we decide.
Yeah, that's
The
what decide which
configuration
one.
file is what's going to pick up what you want to,
Yes.
which of the kernels you want to run.
Yeah. Yeah.
Okay.
But if you're running down the both kernels on the same system, might as well put all the config in one kernel, right? Unless you'll be compiling for another device. So you can do that. So like I said, for a day-to-day user, it's a rare case where you want to do your custom kernel because there's not much need for it. Most of the thing there.
Because you want to make the image smaller, lighter.
Yeah, you
Because I
want
can
to
see
make
it's got every damn driver. in
yeah,
the
you
world.
have to make it smaller and also maybe
But
some
it's quite small anyway, 15 megabytes. Is that
15, not even 50, 15.
one? I know 15
One five.
megabytes.
Yeah, it's very
That's
small.
quite a small.
Yeah, it's small.
It's quite small.
The JavaScript developers can relate.
Well, the what?
The JavaScript developers,
JavaScript, I know.
those guys are messing with our ecosystem.
Or Python. It's
No, Python is a Golang. Golang is also
JavaScript,
huge.
and that's interpreted, isn't it?
Yes.
The interpreter, yeah.
And that's the problem with the interpreter.
Yeah.
interpreter.
The other one,
As
the
opposed
compiled
to-
one is my problem is Golang, so it's also huge.
Yeah.
You make a hello world, it's 20 MB for a hello world.
20 megabytes to hello world.
So yeah,
Where C gives you like some 10
20
kilobytes or
20
something.
kilobytes. So do you have any question here? You mentioned you use Arc as well.
Yes.
So it's familiar for you. How was the installation for you, by the way?
At the time I was installing Arch, I didn't know of Arch install any
Okay.
other. I had very little to no idea of what I was doing. So I was confused like 90% of the time. So I had Gemini there, like live mode, helping me get my way, like get
Okay.
through the installation process here.
Okay. So but then you now also Arch install the documentation.
Yeah, I never used Arch install. By the time I found out of Arch install, I'd manually set up almost everything I needed. So I didn't need to
Wait,
use.
when you talk about Arch install, is it a package?
It's a guide.
Yes, it's a TUI terminal user interface that helps you.
No, it says a terminal.
It's TUI as an GUI, but
Okay,
in the terminal.
okay, terminal with end courses kind of thing.
Yes, and then it helps you set up your your window manager, your file
Oh,
manager.
you just select and select and select.
Yeah,
Oh,
so you
okay.
select them and then it installs.
Customize for you.
Hmm.
You select what you want. And then I will select something.
Actually, I didn't know the Arc has a feature because usually you do your partition yourself. You do the everything yourself.
So I think Debian has also, if it's an Arch thing, then Debian has also, started doing that because Debian now has something like a mini installer, which when after you install it, then it's so you finish your installation, then it asks you, okay, what browsers do you want, what this do you want.
That's
It
even
doesn't.
that's easier. Let me see.
Yes.
That's easier.
Yes,
Where you
that's
say what browser, what desktop manager you want
Yeah.
to run. In Arc, there's no feature of what is. They give you a terminal, you start. So that's why I say the installation. Because the first, the Arc I get, if I still have the image, let me see if I still have the Oracle. If I still have an image, maybe I can show you the installation here. My file. Let me see if I have image somewhere. Okay, yeah, I do. So let me load up an Arc image. You see what I mean? Yeah. Arc, and then we are in this part. The ISO image. This is going to order. Yeah, I have Arc here. Let me just save this. Finish. So this is an ISO or something else. Okay. It's what happened. As root. This is not loaded. Okay, this kernel, I don't have this module anymore. Yes, I have to reboot to the other one. VBox. Well, let me quickly do the reboot.
Are we done?
Yeah, we are done. We're just doing the discussion. So
So I don't know how everybody is, but some of us can still stay.